So this is the energy of a pickleball if it were to be rolled down an inclined surface and determining its velocity at certain points. So the question that I'm modeling is, if I were to let a pickleball slide down a railing from a starting position of x equals 0 feet, what would the velocity be just before it hits the ground? And what would the velocity be when the ball hits the ground? So we would be looking at point B at the end of the railing and point C, which is the ground, for what the velocity is. And to model the scenario.
What is my phone? Is my
Yes.
phone? Okay. Ready? Go. What is my phone?
Yes.
Okay. Ready?
So for the parameters, we would look for the height from point B to point A, which is the bottom of the railing to the top of the height to point A. The height from point C to B, the bottom of the railing to the ground. The length of the railing, which has a displacement of 92.5 inches, which is equal to 2.35 meters. And the length of the railing, which would be the distance from point A to point B, but from the top of the triangle. So it would be distance rather than displacement. Now, to find the velocities of those given points, the theory behind this would be the work energy theorem, which states the net work, which is the sum of all work done by the forces done on an object, is equal to its change in kinetic energy, the energy the particle possesses due to motion. And now we could apply this because the applications may include, well, for this scenario specifically, it includes analyzing motion of a particle such that the final velocity of an object after it has been acted upon by a known force of a certain distance. So the particle in this case would be the pickleball, and it's being acted upon by gravity, which therefore would have a constant velocity. So our givens would be, it starts at 0 meters, it ends at 2.35 meters, based on converting feet to meters. The velocity from point A is 3.05 meters per second released from rest. We got that from the delta distance over delta time, and the change in time, which would be 0.77 seconds. The conversion factor of 1 foot is equal to 0.13048 meters. And then we also have the weight of the ball in case we needed it. And we're going to assume air resistance and friction are negligible, because since the railing is smooth, the only work done upon the pickleball will be due to gravity. And the drawing displays the pickleball as it goes down the railing and lands at the end of the railing. And when it hits the ground, points B and C, and we'd be looking for their velocities at these specific points in time based on the information that was already given to us. So we know that because this height is 52 and 3/8 inches, and this length is 76.4 inches, we're able to find the total distance of the railing, which would be the displacement, which is 2.35 meters. Originally, we found it in inches and converted it from inches, which would help us to find the exact velocity at point A, which will help us to use the work energy theorem to solve for the certain velocity at point B, just before it hits the ground, and the certain velocity at C when it hits the ground, which we concluded as 32.1 meters per second and 42.0 meters per second.